Hello everyone, and welcome to another special class today. In the previous video, we discussed some things that pertain to mechanisms of electrolysis. We also discussed the factors that determine preferential discharge of ions. Now, in this video, we shall be discussing two very important categories of things with respect to electrolysis. We shall discuss applications of electrolysis. We are also going to be discussing the two Faraday's laws of electrolysis, as well as solve some simple problems relating to electrolysis. Applications of electrolysis. Number one application is that electrolysis is applied in the purification of metals, purification or refining of metals. Now, such metals as silver and copper can be purified or are purified by means of electrolysis. Now, during the process, the impure metal is made the anode, is placed at the anode. Now, a strip of the pure metal is placed at the cathode. Now, the electrolyte is made a salt of the metal being purified. For instance, when you want to purify copper, you make the pure copper the cathode, the impure copper is placed at the anode, whereas you use copper 2 tetraoxosulfate 6 solution as the electrolyte. Electrolysis is also employed during the extraction of metals, of highly electropositive metals such as sodium, potassium, calcium, and aluminium. For instance, you extract sodium from sodium chloride through the electrolysis of fused sodium chloride, whereas aluminium is extracted from alumina, that is aluminium oxide, molten alumina. So molten alumina is used as the electrolyte, and by electrolysis, aluminium is extracted. Another application of electrolysis is in the production of gases. Such gases as hydrogen and chlorine and oxygen are prepared by electrolysis. For instance, the electrolysis of brine, that is concentrated sodium chloride, is used in preparing chlorine and hydrogen. We have seen this in the previous video. And the oxygen is prepared by the electrolysis of copper 2 tetraoxosulfate 6 solution using graphite anode. Electrolysis is also employed in electroplating. Electroplating is the process whereby a thin layer of a metal is placed or is deposited on another metal by means of electrolysis. Now, for instance, you can actually silver plate or copper plate. What you have to do is that the metal that is being plated is made the cathode, and the plating metal is made the anode. And now the salt of the plating metal, for instance, now in the case of silver plating, you get a silver salt and make it the electrolyte. And the last application of electrolysis, which we are considering today, is in the preparation of certain compounds, such as sodium hydroxide. We saw this that during the electrolysis of brine, that electrolysis of brine can be used, can be employed in the preparation of sodium hydroxide. Sodium hydroxide pellets can be prepared by that electrolysis. Now, let's talk about Faraday's laws of electrolysis. There are two Faraday's laws of electrolysis, and we are discussing the two of them. The first law of electrolysis by Faraday states that the mass of an element deposited during electrolysis is directly proportional to the quantity of electricity passing through the electrolyte, which means mass is directly proportional to Q, which is quantity of electricity. And we know that quantity of electricity is the same thing as the product of time and current. So mass is directly proportional to the product of time and current passing through the electrolytes. Now, it is very important that we take note of certain things. For instance, what we call Faraday, the quantity of electricity that is required to deposit 1 mole or to discharge 1 mole of electrons is called 1 Faraday. The quantity is 96,500 coulombs. 96,500 coulombs. Of course, we know that a mole of electron contains Avogadro's number. That is 6.02 exponential 23. So the quantity of electricity that is required to discharge 1 mole of electrons, or to carry 1 mole of electrons, is 1 Faraday. That is 96,500 coulombs. So we see the following formula, the formula that we can see now on the screen. Is very important for us to solve some problems regarding electrolysis. We see that N, which is number of electrons, is equal to M, that is mass over molar mass. Yes. Which is also equal to quantity of electricity, or IT, over C. That C is the charge on the ion, and F is Faraday, which is 96,500. This formula is very important for us when we start solving some problems. Now, let's consider Faraday's second law of electrolysis. It states that when the same quantity of electricity is passed through 2 electrolytes connected in series, the amount in moles of each element liberated is inversely proportional to the charge on the ion of the element. When the same quantity of electricity is passed through 2 electrolytes connected in series, the amount in moles of each element deposited is inversely proportional to the charge on the ion. So the formula above is constant. Now we have it that NC is constant, such that N1C1 is equal to N2C2. It's going to help us, this formula is going to help us in solving problems. Of course, you know that N is equal to M over capital M, small m over capital M. Thank you very much. We shall now proceed to solve a few problems using this formula. Now we look at some examples on electrolysis. The number 1 example, a current of 0.72 amperes was passed through a solution of an electrolyte for 3 hours 20 minutes. Calculate the quantity of electricity that was passed. Now in the solution we have the parameters given there. We see that time, converting time to seconds will give us 12,000 seconds. So we use the formula Q is equal to I times T, that is current times time, which is 0.72 times 12,000 seconds. And we see the answer there in coulombs. Now we have the second one. How many moles of copper will be deposited by 4.0 moles of electrons during the electrolysis of copper, aqueous copper 2 tetraiosulfate 6. Now in the solution there, the first thing we need to do is to write the equation for the discharge of copper 2 ions. So we have copper 2 ions there, and we have that from the equation 2 moles of electrons gave 1 mole of copper. Therefore, 4 moles of electrons will give 4 over 2 moles of copper, which is 2 moles of copper. Now let's look at the number 3 problem here. An element M has a relative atomic mass of 88 when a current of 0.5 amperes was passed through the fused chloride of the element for 1930 seconds. Now the mass of the element deposited was 0.44 gram, and it was of course at the cathode. We are asked to calculate the number of Faradays needed to liberate 1 mole of M, to write the formula for the ion of M, and to write the formula of the chloride of M. The first one, to find the number of Faradays, we know that number of Faradays is equivalent to the charge on M. So we use the formula M, that is mass over molar mass, is equal to product of time and current over Cf, C being the charge and F being the Faraday. So we have all the parameters given to us there. Of course, Faraday is 96500. Now we are required to find C. So making C the subject of formula and substituting, we have that C is 2. Therefore, 2 Faradays will liberate 1 mole of M. Reaction at the cathode, therefore, is M2 plus 2E, giving us M solid. Now, the B part of the equation, the formula for the ion is M2 plus. And the C says the formula of the chloride is MCl2. Let's check question number 3. Question number 3 says, explain why different quantities of electricity are required to deposit 1 mole of copper and 1 mole of silver, respectively, during electrolysis. The solution: copper and silver, of course, they have different charges. So here are the equations showing their discharge. So from the above equation, it's obvious that why 2 Faradays, that is 2 moles of electrons, are required to discharge 1 mole of copper. 1 Faraday, that is 1 mole of electron, will be required for 1 mole of copper. So that is the explanation. Now we have question number 5, and it says calculate the mass of lead that will be deposited from a solution of lead 2 trioxynitrate 5 by the same quantity of electricity depositing 1.35 grams of copper from a solution of copper 2 salts. Now we have the constants there, that is their relative molecular mass is there given. Now in the solution we are to calculate the mass of lead in a series arrangement with copper. And we have all the parameters given there. We are looking for X. Now, since lead and copper have the same charge of +2 each, so we have that 1 mole of lead is equivalent to 1 mole of copper, same quantity of electricity, which means that 207 grams of lead is equivalent to 6.3 grams of copper. Therefore, S grams of lead is equivalent to 1.35 grams of copper. We are equating them here this way because they have the same number of charges, so they require the same number of Faradays for their discharge. So X is now 4.35 grams of lead. Now let's consider the 6th question. In an electrolytic process, solutions of copper 2 tetraiosulfate 6 and dilute sulfuric acid were electrolyzed in series. If 1.27 grams of copper was deposited, calculate the volume of oxygen liberated at STP. And we have all the constants given there. So to calculate the volume of oxygen liberated in a series arrangement, given that the mass of copper is 1.27 gram, and we have the equation for the discharge of oxygen, or for the deposition of oxygen, we have the equation there. Since 4 Faradays are required to liberate 1 mole of oxygen gas, and 2 Faradays are required to liberate 1 mole of copper, a serial arrangement, it follows that 2 moles of copper is equivalent to 1 mole of oxygen. That is 2 times 63.5 gram of copper is equivalent to 32 grams of oxygen. Therefore, we have it that 1.27 grams of copper is equivalent, requires the same quantity of electricity to discharge 0.32 grams of oxygen. But we're not asked to determine the mass of oxygen. We're looking for its volume. So we see that at HTP, 32 grams of oxygen, that is 1 mole of oxygen, occupies the volume of 22,400 cm3. Therefore, 0.32 grams of oxygen will occupy 224 cm3. Okay, thank you very much. This is where we are ending this particular video. See you next time. Don't forget to subscribe to the channel and look up for our next video.